Hello everybody, we're going to be solving a neat problem that results from electric forces and fields. So this problem says that there are two spheres that are fastened to a string that that is 0.6 meters long. The two spheres both have an identical charge Q, and they both have a mass of 2 grams. This question asks us to determine the charge that both of these spheres have. Oh, and we're also told that because the charge is identical, the two spheres repel each other and reach an equilibrium position. And that position is occurs at 30 degrees. So the easiest way to solve this problem is to first draw a force body diagram. So we know that the electric force is perpendicular to the force of gravity. So there are two arrows, and so this is the electric force and this is the force of gravity. Now note that we are drawing this force body diagram from the perspective of the left sphere. There's also tension in the string, and that is at an angle Ft, the tension force. Now the angle at which that occurs, however, is 15 degrees, because if you were to just remember this, if you draw like an angular bisector, so this angle would be 15. So we'll just so if we were to draw its component vectors, we would get Ft sine 15 degrees, and this would be Ft cos 15 degrees. Cosine of 15 degrees. Okay, so this is all the information we need to determine this charge of that we have denoted by the letter Q. So we know that Ft cos 15 is equal to the force of gravity. So we're going to equate that and we're going to find Ft. So we're going to say that Ft cos 15 degrees is equal to mg. And so we know what cos 15 is, and we know what mg is. So we can then isolate for Ft, and I've done the calculation here, guys, and it turns out to be 0.0203 newtons. Okay, now that we know what the tension is in the string, we can now determine the electric force. Alright, so first let's determine what Ft sine 15 is. So I'm going to use a different color here actually. I think I'm going to use yellow. Alright, so Ft sine 15 degrees is because we know what Ft is and we know what sine of 15 degrees is, we know that Ft sine 15 is 0.00525 newtons. Okay, we also know that both of these, so we know that that the equilibrium occurs at 15 degrees, and because we know that it is at an equilibrium position, Ft sine 15 is equal to the electric force. Okay, so let's picture that for a second. We're saying that the horizontal component of the tension, the force of tension of this string, is equal to the electric force. This only stands true because the two spheres are at equilibrium position, that means they're stationary. So the charge, so basically this is the electric force that results from both of these having an identical charge. This is the electric force, and if the horizontal component, so if Ft sine 15 didn't exist, this sphere would just keep on going because there's a force and there's nothing to oppose it. But because of this force right here, this force opposes the I guess the leftward motion of the sphere and causes it to be at an equilibrium. And because it is at equilibrium, I guess I'm just going to write Ft horizontal. Okay, because they're at equilibrium, this force is equal to this force. So so we're just going to equate that here. We're going to equate that here, and we're going to find what the two charges are. Alright, so we know from Coulomb's law that the electric force is equal to the Coulomb's constant times charge 1 times charge 2 divided by the distance between them. Okay, now we know what this is, and we're trying to find the two charges. And because they are the same, all we need to determine is the distance between these two spheres. So we're gonna solve what the distance is between them and come back to this formula. Okay, so to solve that distance, we're going to use a little bit of trigonometry. We know, okay, if we were to, I guess, draw this out here, we'd get something like this. We're going to get an isosceles triangle. And we know that this line right here is the angle bisector, and this is 15 degrees. This is, we'll call this D. We'll call that D, and we'll call that distance R. Okay, so we know that sine of 15 degrees is equal to this distance divided by this length right here. And as this question has told us, it is equal to 0.6 meters. So we're going to write that down right here. So 0.6 meters. We're going to solve for D, and D turns out to be 0.15529 meters. So in this case, R is really just 2D, which is 0.31058 meters. So now we're going to take R and we're going to substitute it right here. Okay, so once you do that and you solve for Fe, so you solve for the Q, oh, and actually let me just rewrite that. Because Q1 is equal to Q2, we can rewrite this to be Fe equals K, so that's the Coulomb's constant, Q squared divided by R squared. So if you were to isolate for Q, you would get Q equals Fe R squared divided by K, and the whole thing square rooted. Okay, so once you substitute the value of Fe, the value of R, and Coulomb's constant, and you solve for Q, you would get a value that is equal to, let me just write it here. I think red is good. Okay, and and that value is equal to 2.373 times 10 to the negative 7th power coulomb. And this is the charge that is in each of these spheres. So there you go, guys. I hope you enjoy. I hope you enjoyed watching this video. Let me know how it did, and thank you for watching.